Hey, young grasshoppers. So today we are going to do lesson 3, which is introducing the concept of polynomials. Now, in grade 9, you would have spent, hopefully, a long time on polynomials. You would have talked about what like terms are, how you should represent a polynomial, how you get the degree of the polynomial, words like coefficients, variables, all of that should sound roughly familiar. I'm going to start at the basics again though, just to make sure if some of those words didn't sound familiar, hopefully by the end of today they will sound familiar. Okay, so there's a lot to go through in this note, but I'm hoping that a lot of it will be, oh yeah, I remember doing stuff like that, and that you'll feel good about it. Okay, if you leave this note not feeling good about it, don't stress. That just means that we're going to have to do a little extra practice just to bring you up to speed. Okay. All right. So again, warm-up problem. If you'd like to try it, you can give me a pause and then I'll throw the answer here. All right, so some vocabulary for us to talk about. A term, first of all. A term is each part of an expression that's separated by a plus or a minus sign, okay? So if I was to write 2xy, like that, that is a term, okay? Because there is no plus or minus sign there, so there's one thing there. If I was to now go plus 1, that's now 2 terms. I've got this term, and I've got this term, okay? So as soon as you see a plus or a minus sign, that's what's creating the next term. A constant term, if you are constant, it means you don't change. A constant term is a number that will always have the same value. This means there's no variable attached to it. So in this example I gave you, the 1 would actually be a constant term. There's no way to change that. It's a 1, okay? A variable is a letter or a symbol that may be replaced or substituted by numbers. Okay, expressions are formed by combining constants, variables, or both by adding, subtracting, multiplying, or dividing. So what I've shown you up here, that's an expression, okay? What's the difference between an expression and an equation? An equal sign, okay? As soon as I put equals something here, say I put equals 2, that's no longer an expression, now it's an equation, okay? Numerical coefficients are the numbers that you find in front of the variable expression. So in this one, I have x and y as variables in this first term. The numerical coefficient for that would be a 2. A polynomial, poly and nomial are actually 2 Latin words. Poly is Latin for many, and nomial is Latin for numbers. So a polynomial literally translates as many numbers, okay? It's an expression of 2 or more algebraic terms that are being added or subtracted. Now, there are some special types of polynomials. Remember, just because we have special types doesn't mean it's no longer called a polynomial as well. Okay, think about a quadrilateral for a second. A quadrilateral simply means a 4-sided figure. But inside that quadrilateral, inside that grouping of quadrilaterals, can't talk today, we have special ones. We have a square. Okay, so a square is a special quadrilateral. It doesn't mean that a square isn't a quadrilateral, though. It's just that because it has a special name, we often call it by its special name. Okay, so some special ones for you. A monomial, first of all. A monomial can consist of any integer, any variable with a positive integer exponent. It's the product of integers and variables. So essentially, it's just one term, okay? If you get mono, which is a illness that is often contracted, people will say, oh, I got tested for mono. That word mono actually comes from the word mononucleosis, which means it's a particular bacteria that infects you that only has 1 nucleus, whereas most cells have 2 nuclei. That had nothing to do with math. I was just trying to, you know, make things interesting. A binomial, if you ride a bicycle, you have a bicentennial. A bicentennial means every 200 years. Bi means 2. So a binomial is the sum or difference of exactly 2 monomials. And a trinomial, if you ride a tricycle or if you go see a triceratops at the museum, tri means 3. So a trinomial is the sum or difference of exactly 3 monomials. All right. Now, the degree of the polynomial is the highest exponent of the variables in the polynomial, or the greatest sum of the exponents of the variables in any single term. Now, what I mean by that, take a look at this guy for a second. We have a term here that has two different variables. The exponent on x is a 1, and the exponent on y is also a 1. So this term would actually be a degree 2 because we add the separate exponents together in the same term. Okay, so this is 1 plus 1, so that would be degree 2. This guy is degree 0 because there is no exponent there. Sorry, there is no variable there. So overall, this polynomial would be a degree 2 polynomial. Okay. All right. We arrange polynomials in ascending or descending order. Ascending is when we write the polynomial from the lowest degree to the highest degree, whereas descending is the highest degree to the lowest degree. Now, if you are not told right in this particular order, if you're just told to write a polynomial, by convention, we would always write in descending order. So the highest exponent should be stated first, and then you work your way down to the next highest, to the next highest, to the next highest, until you hit the constant term at the end. Okay. All right, so as an example, let's take these monomials. This is 1, 2, 3, 4, 5 terms in this polynomial, and we're going to arrange it in ascending order and descending order. Okay, ascending order and descending order. So let's start with ascending first. So we want to start with the lowest. Now, what you have to be very careful of when you start moving around terms is whoever is in front, whatever sign is in front of that term stays with that term, okay? You can look at that as a -7 that I've circled there. You can look at it as a -7. It doesn't matter. They mean the same thing, okay? So if you're moving that around, that negative sign in front must stay in front, okay? One of the things you're going to notice I really try and push you guys to do in senior high is no more of this two different symbols. We're not adding a negative, we're not subtracting a positive or anything like that. If your answer is negative, you're subtracting that number, and if your answer is positive, you're adding that number, okay? So we just always write it with one symbol there. Okay, so the -7 would be first, then we would do the -3x, then we would do the 2x squared, then the x cubed, then the x4. Okay, so when you're writing this in ascending order, you should have ended up with -7 minus 3x minus 2x squared minus 3x cubed plus 8x to the 4. So we went from a degree of 0 to a degree of 1 to a degree of 2 to a degree of 3 to a degree of 4. Okay. If I was to ask you the overall degree of this polynomial, remember we named the overall degree to the highest exponent. So this is a degree 4 polynomial because the highest exponent represented is degree 4. Now, if we were going to do descending, it's just the complete opposite of that. We start at 8x to the 4 and work our way down. A reminder, whatever is in front of those numbers has to stay in front of those numbers. So we end up with 8x to the 4 minus 3x cubed minus 2x squared minus 3x minus 7. All right. Adding and subtracting polynomials. In order to add or subtract polynomials, they must be, and I'm hoping you've heard this phrase before. If not, it's like terms, okay? Like terms mean that they have the exact same variables attached to them, and the variables have the exact same exponents attached to them. So 5x and 7x are like terms. 5x and 7x squared are not like terms, okay? This is also known as simplifying when we're combining like terms together. That's the process of simplifying. So how do we do that? Well, think of your x here as just an apple, okay? So I've got 6 apples and I add 5 apples and then I take away 7 apples, okay? Well, what happens? If I have 6 apples and I have 5 apples, that's 11 apples. If I take away 7 apples, I'm gonna have 4 apples. The point I'm trying to make with apples is you don't touch the x. The x doesn't change, it doesn't become a square, or it doesn't disappear. An apple is an apple. When I put 2 apples together, I have 2 apples, okay? So when I have 6 x's and I have 5 x's and I put that all in the same pile, in my pile is 11 x's, okay? So the x doesn't change there. Okay, so I end up with 4x. Now you try the other two for a sec. Pause me. Okay, so I'm gonna scoot down to the red guy. I had 13x cubed plus 10x cubed minus 8x cubed. Altogether, that gives me 15x cubed. 3xy minus 4xy minus 9xy altogether gives me negative 10xy. Okay? Can we add non-like terms? So now I've got a 6x and a 5y and a minus 7z. There's nothing I can do with that. I cannot simplify that at all. Unlike terms cannot be put together. Okay? If I have 6 apples and 5 oranges and I put them all in a pile and asked you what I'd have, your answer would be, I have 6 apples and 5 oranges. There's nothing else you can say there. Okay? So unless the variables are exactly the same. Now take a look at this pink guy. This is m to the 3 and this is m squared. Those are not like. Okay, they'd have to have the exact same exponent in order to be put together. So that is a resounding no. Okay, so simplify the following. When we do this, what we want to do is we usually want to write another line without the brackets first. Okay, so this is a polynomial x squared plus 3x minus 11. I'm going to add another polynomial, negative 4x squared minus 8x minus 12. Now, in this instance, when we're adding, the brackets aren't really doing anything there, so we can just drop the brackets. This is going to be x squared plus 3x minus 11, and then minus 4x minus 8x minus 12. So I end up with x squared minus 4x squared. That's where I get the negative 3x squared. And then I had 3x minus 8x. That's where I get the negative 5x, or the subtraction of 5x. And then I have negative 11 plus negative 12, and that's what gave me the negative 23. Okay? And I've written it in nice, pretty descending order. Remember, if you're not told, you should always write in descending order. Okay, so now a cubed minus 3a squared plus 8 plus 5a squared plus 19. Since you have to do it in descending order anyway, start with your highest exponent. I've got an a cubed here. Sorry, I can't get my color working here. I got an a cubed here and no other a cubed, so that'll be a cubed at the beginning. Then I've got a negative 3a squared. Notice I'm taking into account what's in front of the number, and a positive 5a squared. So when I put those together, that would give me 2a squared. And then I have a negative 8, or sorry, a positive 8 and a positive 19. Okay, so when I put all that together, I have a cubed plus 2a squared plus 27. Okay, you try this one. Pause me for a sec. Awesome, you should have gotten 3d squared plus 19e squared. Take note that although you had a DE, you had a 6DE and then a minus 6DE, so that equals 0 DE, but 0 DE, that's just nothing. You have no apples anymore, so I don't have to state 0. Okay. Okay, pause me, and you should have gotten 9a squared b minus 2ab squared plus 4ab. Okay, again, I'm just working my way down. I added the a squared b's together, and then I added the ab squares together, and so on. Okay, this is a degree 3 because it's 2 plus 1. That's why I wrote that guy first. Okay, this is also a degree 3. So some of you may be fighting with me and saying, well, why does it matter? An a squared would then come before an a. So once we get into similar degrees, we then start thinking about how you would alphabetize these guys. Okay, so a would come before b, and then the highest exponent on the first guy would come before the highest exponent on the second guy. Okay, so now, what if I have a negative? When I have a negative, you have to be super careful. When there's a negative out there, what happens is that negative gets distributed. So that negative applies to the negative 4x squared, and it applies to the negative 8x, and it applies to the negative 12. So remember I said I don't want all these double negatives or subtracting a positive or whatever. If you are subtracting a negative number, that overall is addition. So you're going to just say that's going to be turned into plus 4x squared, okay? And plus 8x because you're subtracting a negative again, and plus 12 again because you're subtracting a negative. Okay, so we're going to get rid of the brackets by distributing the negative first. So I always would encourage you to have a second line here before you go right to your answer when you are dealing with subtraction. And that second line should be what it looks like without any brackets. Now you can take a look at that and combine like terms. And when you do so, you end up with 5x squared plus 11x plus 1. Okay, super important that you are communicating this stuff nicely. Notice that I'm never working left to right. I'm always working down. Okay, I always start another line below where I was, and that line should start with an equal sign when I'm dealing with expressions. Okay, that conversation will change a bit when we're dealing with equations, but when we're dealing with expressions, we would start the next line with an equal sign, and then we keep going. Your math work, if you're doing a good communication job, it should kind of always look like this triangle that's coming to a point at the bottom, because as you simplify, you're dealing with less and less terms. So the amount of work that you're drawing gets smaller, so you get this kind of triangular shape. Okay. Okay, try this guy. So again, we want to get rid of the brackets first. So I would write this as a cubed plus 3a squared plus 8 minus 5a cubed plus a squared, because I had a negative, and minus 19. Now I can go ahead and combine like terms. My a cubed and my negative 5a cubed would be negative 4a cubed. My 3a squared and my a squared would give me 4a squared. And my 8 minus 19 would give me the negative 11. Okay, try that guy. So again, you've written it without brackets first. I distributed that negative, negative 2x squared, negative 7x, and plus 9. Be super careful. That's a negative. That's where that plus 9 comes from. Combine like terms, and you'd have 3x squared minus 10x plus 11. Okay, try this guy. Lots of practice here because I want to make sure you're super comfortable with this. Remember, the negative will get distributed. So the first line I want to see is what's on top, except all the brackets dropped. So that should look like this. Now we're ready to combine like terms. And you should end up with 9x squared minus 14x plus 4. Okay, quick little review of some exponent laws that you would have needed to have known in junior high. First one, 2 squared times 2 to the 3. I would want you to tell me that that is 2 to the 5. And the reason it's 2 to the 5 is because when we're multiplying powers of the same base, we add the exponents. So a to the m times a to the n would give me a to the m plus n. Okay. Likewise, we have a quotient of powers. So 3 to the 5 divided by 3 to the 2, I would want you to tell me that that's 3 to the 3. And again, the reason is the rule that we have is when we are dividing powers of the same base, we would subtract the exponent. So a to the m divided by a to the n would equal a to the m minus n. Okay, so now if we're asked to simplify this, we are multiplying these guys together. And how we handle that is we multiply the coefficients and we multiply the variables. So 3 times 5 is going to give me 15. And then x squared times x cubed. Well, when we're multiplying powers of the same base, we add the exponents. So that's going to give me x to the 5. So my final answer there would be 15x to the 5. Okay, so we're going to try a couple of these together. Again, I've got 3 times negative 2, so that's negative 6. And I've got x squared times x cubed, so that'd be x to the 5 again. So that's going to give me negative 6x to the 5. Okay, same thing, it's just we do it 3 times. So I've got 2 times negative 5 times positive 4. So 2 times negative 5 is negative 10 times 4 is negative 40. And then a squared, a cubed, and a to the 5 will give me a to the 10, just adding up all those exponents. Okay, when we're dividing, same sort of thing. We divide the numbers or we reduce the numbers. Like if this said 3 over 18, you can't actually divide 18 into 3 nicely, but what you could do is you could think of it as a fraction that says 3 over 18 and then reduce it. Okay, and then same thing with the variables. We will now, because we're dividing powers of the same base, we would subtract the exponents. So 8 divided by 3 is 6. X to the 6 divided by x to the 2 is x to the 4. So I end up with 6x to the 4. Okay, so try this guy. Again, what I want you to notice here is this doesn't come out to be a nice number. You would never write that as a decimal, okay? Welcome to senior high. I do not want to see any decimals in your work, okay? The only time you should ever answer as a decimal is if you're talking about money or the question specifically asks you to round to something. Other than that, your answer should always be left as a simplified fraction. So when you see 8 over 6, I see that as a fraction and I want to reduce that. That would reduce to 4 over 3. I'm just dividing both of those by 2. X to the 4 over x to the 2 would give me x to the 2. And y to the 3 over y would give me y to the 2. Now, your answer should be one nice fraction. So it becomes that 4 over 3. There's where that simplified fraction is. But notice I didn't write it as 4 over 3 times x squared y squared. I wrote it as one fraction. So it's just the whole thing becomes over 3. This is the good way to answer in math, okay? All right, so now try this guy. You can pause me for a sec. 2 times 6 is 12. B squared, b squared, sorry. B squared times b to the 8 is b to the 10. So up top here, I'm going to have 12b to the 10 over 4b to the 5. 12 over 4 is 3. 10 minus 5 is 5. So final answer you should have gotten was 3b to the 5. Okay, so now we're going to further talk about this kind of distributive property. We kind of just talked about this with that negative sign when we were subtracting exponents, but now we're going to throw a number in there too. So what I want you to see in a situation like this 3 has to get multiplied by x, and the 3 has to get multiplied by the negative 4. Okay, so altogether, that's going to end up with 3x minus 12. Over here, the negative 5 has to get multiplied by the 2y, and the negative 5 has to get multiplied by the negative 6. So altogether, that's going to give us negative 10y plus 30. Be careful, you had 2 negatives there. Okay, and then over here, same thing, it's just getting a little more muddy. 3a squared times 2a to the 5, well, that would give me 6a to the 7. 3a squared times negative 4a would give me negative 12a cubed, and 3a squared times 1 would give me 3a squared. Whoops, sorry. Okay. Sorry, the garbage truck just came. I was watching the garbage truck out my window. Okay, simplify the following. 6y minus 2x plus z plus 3x to the 7 plus 5y minus 4z. Well, who's going to come first? When I see that, the highest exponent that should come first would be x to the 7. So x to the 7, 3x to the 7 will go first. I can't combine that with anything. Then I've got everything else is degree 1. So the next thing to look at would be my x, then my y, then my z, because all the degree 1s would fit into alphabetical order. Okay? So if you can combine like terms, do so. Final answer should be 3x to the 7 minus 2x plus 11y minus 3z. Okay. Try this guy then. Nothing out of the ordinary. Final answer should be 12a minus 4c minus 7e. Try this guy. Remember to distribute your negative. So you might want to drop those brackets first just to be on the safe side. Then you can combine like terms. Final answer should be a cubed plus a squared plus 8a plus 7. I'm assuming you are pausing me and trying these on your own. Okay. Again, the plus here doesn't really affect any sign changing or anything like that. So I would still write all of this as one line without brackets first. You don't need the brackets here. You don't need the brackets here. You do need to think about the fact that this negative will get distributed to everything on the next bracket though. So you want to think that through as you go. Okay, so this is with everything, all the brackets dropped. Now I want to try and combine like terms. Looking at degree 4 here, a degree 2. This is a degree 3, a degree 3, 2, 4, and 3. So put your 4s together and then work your way from there. Final answer that you should get is 2m squared n squared plus 2m squared n plus 4n squared m. A reminder, these are both degree 3, but I put the m squared before the n squared because m would come before n in the alphabet. And then minus 2n squared. Okay, now practicing the distributive law. So 3x gets multiplied by x squared, 3x gets multiplied by negative 3x, and 3x gets multiplied by 2. You should end up with 3x cubed minus 9x squared plus 6x. Same thing here. Give it a shot. You should end up with 6x squared y, because you had an x times an x there, and 8xy. And that's where I'm going to stop. Okay, so hopefully this is helpful as you're trying to just make sure you're on the same page with everything. Give your homework a try, and if you have any questions, connect with me. Next, what we're going to do is we're going to move this thought into our next lesson will be on multiplication of polynomials. Yeah, and then after that, we get into the really fun stuff, which is factoring. Okay, so until then, I hope you guys have a fantastic day, and I'll talk to you soon. Bye-bye.